Okay, so this is an overview of a typical debug session that you're going to have to do with Experiment 6. Now, Experiment 6 is just a lot going on. It's going to test all the instructions that you implemented, and it does kind of exhaustive testing. And so the issue here is, you're going to make mistakes, so it's not, simple stuff. So the debug procedure is pretty straightforward, but I want to make sure people have an idea of what's going on so you can get started with it. And so essentially so you can be self-sufficient in debugging your work. So this is this file right here is the dump file. I forgot the name of it, but it's provided with Experiment 6 stuff, and it's the whatever program.dump. I forgot what it is. It might be program.dump. But anyway, it is a dump file. And that, when you say dump file, that can mean a lot of different things. But for us, that means, in my mind, it means the assembly listing file. And so what it gives is just information that's going to be useful to me. Now, the first part of the file is essentially the machine code, and it's a long program. And so there's going to be a ton of machine code, and none of this essentially really is going to help me. You could look at this. Essentially, these are just addresses here, and then followed by 4 lines of four instructions, essentially. But once again, that's, like I said, it's not very interesting to us. It's just a ton of data. But eventually it gets to something useful here. Now, when you start your program, you think it's going to work, and you try it on your board and nothing happens. The very first thing you're going to have to do is come and look at this dump file. Now, this is what's going on, and you have to step through this and make sure things are going right. So the very first instruction, essentially this column over here is the address column, and it's going to step through these instructions. And notice this is machine code or the assembly code doesn't look overly familiar because it was essentially written by the GCC compiler, which is different, and it does its own weird stuff. And so we try to avoid looking at this. But what is important is we can see that it should be stepping 0, 4, 8, C. If you look at C, C is a jump to main. And it's going to jump to the main label. Here's the main label. And it's going to jump to address 18. So your addresses, your program counter is going to go 0, 4, 8, C. And then it's going to jump to 18, 1C, 2024. So that's something worth seeing. And so what I have here is the file and all that stuff, the Xilinx environment. And so I'm going to step through that. So the very first thing I'm going to do is go to my PC here, and I'm going to throw that PC up onto this waveform. And oh, okay, there it goes. It already had the data, so you can see it. 0, 4, 8C, and it jumps to 1, 8, and 1C. So that means it is potentially doing the right thing. Essentially what that means is it took the jump. One of the first thing that's going to go wrong in these programs is the jump is going to be wrong. And that includes both jumps. You had one jump in Experiment 5, but this is going to have both jumps in it. Okay, so that indicates the jumps are correct here. And so what it's going to do in this program is it's going to run these various tests, and these tests are written over here. You can see the add tests and subtests, and these are actually subroutines. And so what you're going to see here is it's going to step through this 1, 8, 1C, 2, 0, 2, 4, 2, 8, 2C, 3, 0, 3, 4, and then it's going to take the jump. And it's going to take the jump to add test. So it should go from 3, 4 to wherever add test is. So let's look at it. Add test 3, 4 to 2, 3C. Let's look at it. 3, 4 to 2, 3C. 3, 4. Okay, yeah. I'm sorry, it jumped somewhere else first. But there's 3, 4 to 2, 3C. And it takes that jump. And we'll go back to this code here. It's going to go through the add test at some point here. it's going to hit 494. This is the address, and this is the date at it. So we're going to verify that works, and this is essentially return from the subroutine, which is the jump instruction. So it's going to go back from 494 to the instruction after the call. Instruction after the call, which is somewhere here, somewhere. Okay, here's the add task call instruction. The next instruction should go to 3.8. So it should go from the end of the add task 494 to 3.8. Let's look at it. Now there's something I want to show you on this thing. I don't feel like pawing through this thing, so I'm going to do a search on this thing. And the way I search on it is I'm going to highlight that thing and turn this and look for that value 494, because this is the program counter. So I'm going to look for it, and let's go. And there it is. So there's my 494 right there. Now the next instruction, with any luck, should be 3.8, because that's a return from the subroutine. Looking good. Okay, so that, I know this works, and so that's what I'm kind of dealing with here. But the issue is what happens when it doesn't work. So when it doesn't work, what you'll see, we'll look at these things. It's essentially going to call this fail subroutine. And so at some point, generally speaking, your program is going to be mostly right, except there's going to be problems with it. And so when there's a huge problem, you're going to it's going to call this fail subroutine. That means something didn't check out, and the fail subroutine is right here. Okay, and here's your fail subroutine. The subroutine it calls is at 21C. So essentially, I can, what I'm going to do here is I can come up here and search for 21C. And I know it's kind of boring because I know this is actually a working version and it's not going to find anything. Hang on. Sorry, I had to let the cat out. But anyway, this is 21C. I need to highlight that thing, and I'm going to do search for the next occurrence of 21C, which shouldn't be here because there shouldn't be any mistakes in this one. And it didn't find anything. Okay, so that means it didn't work. But if there was a mistake, what would happen is, I guess I should have put a mistake in there, but it would find 21C, and what you do is work backwards to see which the address of the instruction that called the fail subroutine. And once I find the address of that instruction, I can come back and look through this code, look through which subroutine that actually caused it to fail by looking at the address before that 21C. So that is most of what I wanted to show you in this thing. One of the things that's happening in this is it is turning the LEDs on. So after every individual test, it will call this update test subroutine. So you go there quite often. When it finishes a testing one instruction, it will also call this end subroutine, which is a poor name for it. But the issue is in the end subroutine, it's going to look for the switches. Now the issue with the switches is if the rightmost switch is on, it will stop the program. It'll stop right there. It'll stop until you turn that switch back on. There's actually a loop in this code that's monitoring the switch. And so that's really what I want to tell you. Once again, the first steps is to see if you're getting this, stepping through these 048C, 181C. It comes to 3.4. It takes the jump, and you can see all this at this point. All the calls to these individual subroutines kind of come in direct order in this thing. So you're gonna hunt down for those things. And hang on. Yeah, sorry, the cat wants in and out. And so that's the best thing I can tell you about this. And most of the mistakes are going to be kind of easy to catch. I mean, this code is very hard to follow. You don't want to try to follow it. Most of the mistakes will be, hey, there's a problem with my given instruction. I'm going to go into the Verilog code and look at that instruction. If you have to look at this instruction, these instructions here, you're going to hate life. You try very, very hard not to do that. It's usually, seriously, 98% of the time, it's not the case. You don't have to understand these instructions. Like I said, they're really hard to use. And quite honestly, they're very problematic because in my life I've never used a lot of these instructions because I use pseudo instructions instead. But yeah, I think that's all I have to say about this. Anytime you debug something, it's kind of a learning process. You're practically required to develop your own style. You can't debug anything unless you know at least something is right in this thing. And the very first thing you want to see is that having it accurately step through these first initial instructions. Once you see that, you can kind of follow the way it's stepping around until you find something that's wrong. But with any debugging, you have to understand the circuit, and you have to start from a known working place. And I guess, like I said, the very first thing is the program counter is going to start at 0 after you clear it, and you can go on from there. So good luck. The big thing is you're going to use this search tool quite a bit. It's very useful, and you're going to use it in conjunction with the program counter values, which is essentially these addresses in this column right here. Good luck. Get questions, chime in.